Hello, I'm Preethi. I'm a second year graduate student with Dr. Prashant Kamath at the University of Notre Dame. This is my poster titled Photo Induced Iodide Expulsion from Mixed Halide Perovskites. In the perovskite community, it is well known that mixed halide perovskites undergo segregation upon photoirradiation into their respective halide rich domains. In our group, it was recently shown that iodide was selectively expelled from a mixed halide perovskite film upon electrochemical hole injection. That is, when an anodic bias was applied, the iodide was selectively expelled from the film into the solvent. So if that was the case, we started asking, would photoinduced holes also cause the same effect, that is selective iodide expulsion? We used the prototypical mixed halide perovskite film, methylammonium lead bromide iodide, with the bromide to iodide ratio of 1:1. These films were immersed in dichloromethane, DCM, because these films are stable in DCM. Then we radiated the film using a white light source with an intensity of 1 sun. If you take a look at this graph here, we started off with a black trace, and upon photoirradiation, the bandage blue shifted, the film changed color from dark brown to yellow, and the final bandage after 16 hours of photoirradiation was at around 520 nanometers. From literature, we know that this value of 520 nanometers corresponds to that of methylammonium lead bromide. So this was the first indication that iodide was getting expelled. Then we took the absorbance of DCM in which the experiment was carried out, and this is the absorbance spectrum that we got. We see a peak at around 298 nanometers and 364 nanometers, and this is characteristic of triiodide. We calculated the quantum efficiency of iodide expulsion. So for that, we used a 405 nanometer laser diode. We took the absorbance of the solvent, and from the absorbance and knowing the absorbance coefficient, we calculated the number of triiodide. Knowing the intensity of the lamp that we used and the energy of the lamp, because we used a 405 nanometer laser, we calculated the number of photons. Quantum efficiency of iodide expulsion, that is the ratio of number of triiodide to the number of photons, was obtained to be of the order of 10 to the negative 4%. Then we took the SEM image of the film before and after irradiation. And as I mentioned earlier, to the eye, it changed color from a dark brown to yellow. And in the SEM2, we could see the formation of pinholes on the film after irradiation. So this was indication that there was loss of some species from the film upon photoirradiation in solvent. So we could see that mixed halide perovskite indeed expel iodide selectively into solution upon photoirradiation. Thank you.